We have one question based on Heron's formula. It says calculate the area of the shaded region. As you can see in the figure, there is some portion of this figure which is shaded. We have to get the area of this shaded region. So it's very clear that from this whole area, right, a triangle ABC, from this whole area, triangle ABC, if we subtract the area of this triangle AOB, right, if we subtract the area of this AOB, we are going to get the area of this shaded region. So for that, what we'll be doing, we'll be first finding the area of this triangle ABC. Now, in order to find the area of this triangle ABC, this whole triangle ABC, for that, we need the third side. As you can see here, two of the side is given to us. One is 14 centimeter, other is 15 centimeter, but the third side here is missing. As you can see here, this third side is not there. Now, what we can also observe that this is actually a right angle triangle. So in order to get the length of AB, we can apply Pythagoras theorem to find out. As you can see, AB is the hypotenuse here. So we can use Pythagoras theorem and say square of the hypotenuse, which is AB here, is equal to AO square plus OB square. Now, after that, we are going to place this value OA, which is 12. So that is 12 square, and OB, which is 5. So that is 5 square. That implies AB square is equal to 144 plus 25. So that implies AB square is equal to 169. This gives the value of AB as under root 169, which is 13 centimeter. So we got the length of this AB, which is 13 centimeter. This is 13 centimeter. Now, here onwards, you can see that we know now we know the length of all three sides. So we can apply Heron's formula to get the area of this triangle called ABC. Now, for that, we need the Heron's formula. First, I should tell you how do we get what is the Heron's formula. It is first we find out the semi-perimeter, which is half of the perimeter, and then finding the area. It is whole under root. This is S minus A into S minus B, that multiplied by S minus C. So we need to get S first, and S is calculated. We are going to calculate S, which is A plus B plus C divided by 2. So I can take A, B, C are the sides of the triangle, which I can see here is 13 plus 14 and 15, that divided by 2. So this is S. If I find its sum, it's 42 over 2. So we get S as 21. So once we get S, now we can find the area. Once we get S, we can find the area of this triangle using this formula. We have this formula for finding the area. So A is equal to whole under root S, which is 4. I'm replacing S with 21. S minus A, say 21 minus 13. S minus B, which is 21 minus 14. S minus C, which is 21 minus 15. So therefore, we'll get A now, A here. Yeah, we are getting A here. Now reducing it, this is 21, 20, this is 21 minus 13. So that will give you 8. And then 21 minus 14 will give you 7. And 21 minus 15 will give you 6. Now we'll not multiply them. As you can see that we have to find square root. So start splitting this. I can see we have a 7. So try splitting 21 in terms of 7. So I'll write 21 as, I'm writing 21 as 7, 3 into 7. Writing 8 as 2 into 2 into 2. And keeping 7 as it is, and 6 as 3 into 2. Now, what you need to see that we have a doublet of 7 here, right? You can see for finding the square root of this, I can see we have a doublet of 7. So we can take out 7 outside. So now I will say that area is equal to 7. Now I have to choose the other doublets also. I can see there is a doublet of 3 as well. There is a doublet of 3, right? So we can write 3 outside. And likewise, you can see there is a doublet of 2, and there is one more doublet of 2, that is. So therefore, finally, we'll say that this area will be 7 into 3, 21. 21 into 4 is 84 centimeter square. So this is area of the triangle ABC, but we need to get the area of the shaded region, which you can see whatever the area we got here is the area of triangle ABC, right? This is area triangle ABC. We got the area of triangle ABC, but as you can see the figure from the figure that from the area we have to subtract from the area of the whole triangle, we have to remove the area of this triangle in order to get the area of the shaded region. Now, here we are not going to apply the Heron's formula for finding the area of triangle AOB, right? As you can see, it's a right angle triangle. It's a right angle triangle. And for finding the area of a right angle triangle, when we know the base and altitude, we find its area. So yeah, I'm going to find the area now. Area. This is triangle AOB, which is equal to half into base. Clearly, base is 12 and altitude is 8. So we can reduce it further. 2 1 times, 2 6 times. So we'll get the area here as 8 into 6, that is 48 centimeter square. Now, once we got this, then the final answer will be the required area. So the required area or the area of the shaded region clearly will be 84 minus 48. Because from the given area, we have to subtract the area of the shaded region. So we'll subtract 48 from 84, and that will give us 36. So that 36 centimeter square is the area of this shaded region. It seems we have done a mistake. This is not 8, this is 5 instead. Right. You can see from the figure, this is 5, not 8, right? So we'll get a different answer here, right? So this is 5 into 5, that is 30, right? And then we will be subtracting 30. So on subtracting 30 from 84, we should get 54 centimeters square. That should be the final answer.